Yeah, right? So now we step to our systems of equations from the other perspective, looking at our sculpture from a new way. And this way is with three unknowns, right? And so now, like, really, I mean, if we were to do this geometrically, we're kind of stepping into a three-dimensional space because now we're off of, an X and a Y coordinate system. Now we're on an X and a Y coordinate system with a Z plane running like this, right? And so now we're kind of floating above and below that X and Y coordinate system. We're not going to get into graphing these things, but we could find a solution for them. And, in terms of solving systems of equations, right? Remember, the idea is that we're finding one value that makes all of the equations true at the same time, right? So if you think about a problem like number one, we're looking for some value X, some value Y, and some value Z, that when we were to plug those into these three equations, we would get true statement, true statement, true statement. That's what we're looking for, okay? And so how we do that is a little bit, I guess tedious is the right word. So yeah, let's just kind of jump right in and take a look. Okay, so here's what we're going to do. We'll kind of walk through this process real quick. So we have three equations in three variables, all right? And so we're going to choose two of our equations, and we're going to figure out how can we easily eliminate a variable. If you want to highlight or underline, the first step is we're going to pick two of the three equations, one that we can easily eliminate a variable. So we're going to get it down to two variables, okay? We're going to get two of our equations down to two variables, all right? Then we're going to get the other one down to two variables as well, because we're going to use a combination of the equation we didn't use. Okay, so we're going to pick two. It means we're going to be left with one. So we're going to use one that we didn't use and one of the ones we did use, and we're going to eliminate the same variable. So it's important that you eliminate the same variable. Okay? Now, we'll be left with what we would call equation A from step 1 and equation B from step 2. And those are going to be both in two variables, which we then can set up as a system of equations, solve, and then use those pieces of information that we figure out to go back and figure out our third piece of missing information. Okay? So I think really the best way to do this is let's just do one together so that you get a feel for how to do it. Okay? So try to space your paper out the way that I do because there's a lot to write on here, and so I want to make sure that you have plenty of room. All right, one recommendation I would make is let's just number these equations so that we can reference them easily. So I'm going to call this equation 1. I'm going to call this equation 2. I'm going to call this equation 3. That. And our first objective is to pick two of these three equations where we can easily eliminate a variable. Which one should I use? Yeah, 2 and 3 seems reasonable, right? We can easily get rid of a y. All we got to do is multiply one of them through by -1, right? So let's do that. So we're going to say here, just so that we're clear here, and if you want to box this in like step 1, okay, we're going to use equation 2 and equation 3. And so we're going to rewrite those two equations right here. So I'm going to go 5x plus y plus 2z. Cross your z's, please, because that 2z will turn into 22 faster than you know it. All right? 10. And then I'm going to go 3x plus y minus 8z is equal to -28. And then we're going to multiply both sides. We'll just use the bottom one through by -1. And then we'll rewrite our problem. Like that. Everybody good with what I did? Okay, we're going to turn this into one big addition problem. Of course, our y terms are going to eliminate, which was the goal. And we'll call this equation A is going to be 2x plus 10z is equal to 38. So we've eliminated one variable from equation 2 and equation 3, and we've gotten the rest of those terms crunched together into one new equation. Make sense? Okay. All right. Let's do a little divider here. Okay, so now, step 2, we're going to use one of the equations that we used and one of the equations that we didn't use, and we're going to eliminate the same variable. Okay, well, this is just kind of dealer's choice. I'm going to use equation 1 and equation 3. So I'll rewrite those. So I'm going to have 2x minus 6y plus 9z is equal to negative 8. So that's my equation 1. My equation 3 is going to be 3x plus y minus 8z is equal to negative 28. So for this second step, we're going to definitely use one of the 3 equations we didn't use, and then either of the other 2 is fine. Doesn't matter which one you use. Okay? So if we started with 2 and 3, then we either got to do 1 and 3 or 1 and 2. Your choice. Okay? And then we need to eliminate the same variable. Well, in this problem, we eliminated the y, right? And the reason why is we're going to set this equation with whatever we come up with over here as a system to solve. So obviously we want the same 2 variables, right? So we're going to eliminate y. So then what would we multiply by here? 6, right? Positive or negative? Positive 6, right? Because we already have the opposite signs. Okay, so you go ahead and do that. And then rewrite your problem, and then add them straight down, and get your equation B like I have equation A there. All right, go ahead and do that. Up with equation B, 20x minus 39z equals negative 176. Did you get that? Yes? Let me see around the room who got that. Yes? Good? Okay, good. All right, cool. All right. Now we're going to do a big, long divider. Now, step 3 says we're going to take our 2 new equations that we made in step 1 and step 2, and we're going to set them as a system of equations, and then we're going to solve for one of the variables, okay? So that means we're going to take our 2 equations here. Equation A, which is 2x plus 10z equals 38, and then 20x minus 39z is equal to negative 176. We're going to solve that system of equations. So go ahead. Do that. Let's see what you do. You got here. And hopefully you saw the easiest way to do that was to multiply by negative 10, right? I mean, you could have done that a more complicated way, but I wouldn't recommend that. But you can, you know. And then from there, we would take our z term and go back to one of our equations and plug it in, right? So I'm just going to use the first one. So I'm going to go 2x plus 10z is equal to 38. All right, so then I get 2x plus 40 is equal to 38. 2x is equal to negative 2. X is equal to negative 1. How's that work? Everybody okay? A little tedious, like I said, but not super hard. It's just a lot of solving systems of equations. Okay, and then lastly, and we'll do a little divider over here. Now that we know x and we know z, we can go back and we can figure out y. And we can use any of the original equations. Like I'll use equation number 2. So then I'm going to go 5 times x plus z, or sorry, plus y, my bad. Plus y plus 2 times z is equal to 10. So then I get negative 5 plus y plus 8 is equal to 10. Y plus 3 is equal to 10. Y is equal to 7. And then oh, did I write that wrong? I wrote that wrong. My bad. There you go. Three-dimensional ordered pair. Solving systems of equations. Just looking at the statue from a different perspective, you see a little more detail, like what to do when you have 3 variables. Okay? Questions? No? Feeling confident-ish? Okay. Number 2. Go. Number 2. Go. Yeah. You should have gotten that. Yeah? You good? You got it? Okay, good. Right on. Okay. Now, you may have chosen to go about it a different way, which is kind of hard for me to assess and evaluate for you. I mean, I can look at your individual problems, but this is how I chose to go at it. I went with 1 and 2. I think all of us should have chosen 1 and 2 initially, right? Because the 3 Z's eliminate pretty easily. And then it's where you go from there, so. I do it wrong. Yeah. Because I have to eliminate the same. Yeah, you have to eliminate the same variable, right? So here we eliminated z, so then we have to eliminate z here. They don't have any common multiple other than 33. So I had to turn this into a 33 and turn this into a 33.
What's like your all-time record for sprint?
Yeah. You should end up with the same answer. Should is the operative word here, right?
Why does do you get it? I thought you multiplied 1 by 4, so why?
Where are we talking about? Yeah, in this first one, we eliminated z. So then we have to eliminate z in the second one because we need to create a system of equations in the same 2 variables. And then we can solve that system. Okay. Yeah, we're good. All right, now I know these can be a little daunting. Okay, let's take a look at some applications though with 3 variable problems. So, backside of your paper. Now, on the back side of your paper here, you'll notice that the numbers go a little weird. It goes like 1 and 2 and then 6 and 7. That's because there's another paper that I'm going to give you just for you to have if you want to like practice some of these to make sure you have it down. that I will give you that is not required homework, that is questions 3, 4, and 5, but I didn't want to do that first. I wanted to do the word problems first. So I kind of copied them out of order. That's why it goes 1, 2, 6, 7. Okay? All right. So applications of 3-variable systems of equations. All right. Theater sells 3 types of tickets: general admission, senior citizen, and child tickets. Okay? Mark bought 9 general admission, 2 senior citizen, 3 child, paid $170. Sarah bought 5 general admission, 4 senior citizen, 7 child tickets, paid $173. Kyle bought 4 general admission, 1 senior citizen, 6 child, paid $116.50. Find the cost of each type of ticket. Well, I mean, it should be pretty obvious what the equations are, right? Like, I mean, these should be easy equations, right? But let's define our variables first, okay? Just for sake of your answer matching up with what I put up on the screen, okay? I'm going to go like this. I'm going to say X is going to be general admission, and then Y is going to be senior citizen, and then Z is going to be child. Okay, and then the space is yours. Use it how you will. Okay? All right.
Oh, I know what we're doing.
Yeah. I'll start by giving you the equations in just a second, but I think everybody should be able to get those pretty easily. But I'll give you those that much, and then we'll take a look at the answers. All right? Ready to go. You got the 3 equations right. This is what you should have put right here. All right. So solve it and then write the answer in terms of the context of the story. So for our general admission senior citizen question, you should have come up with this right here. Yeah? Okay. Okay.
34.4 actually.
Jay got something. I got something.
So that's really expensive for
That's exactly what I thought. That's exactly what I thought. But then I was like, maybe they just charge the elderly. If it's Warren Buffett, they might want to charge him $30.
I don't know. Warren Buffett pays like $2 for breakfast every day.
That's why he's wealthy.
Yeah.
He's wealthy because he doesn't ever spend money. Okay. How do we do? How many people got that right? Finished it and got it right? No? Yeah? Good? Okay. All right. How many people finished it and got it wrong? Okay. All right. How many people didn't finish it at all?
Yeah, that was
Okay. At least you're on the right track, right? Okay. All right. Okay. So let's do the next one. Okay. So let's do the next one. So it says Jamie has a collection of 78 nickels, dimes, and quarters worth $12.40. If the number of quarters in the collection is doubled along with the other coins, but just the quarters are doubled, the value becomes $22.15. How many of each type of coin does Jamie have? I'm going to use N, D, and Q for nickels, dimes, and quarters. Okay? All right. This is yours from the get-go. Okay. Get her in.
So remember that your value of nickels is really
Okay, here are the equations.
Oh, wait, I didn't take into account the value.
Oh, you didn't?
Be on the lookout for the opportunity to do that.
That's what I was finna do. Did you?
That's exactly
What happened there? You see what happened there? I was able to eliminate 2 variables because, again, the whole idea, right, is for us to get from 3 variables to 2 variables to 1 variable to plug back in to find the second variable, to plug back in to find the third variable. So if you can get there easier, you know, by all means, be on the lookout, at least possibility for it. Which this is what you were trying to do initially, yeah. But it does work. You just have to have that set up. You have to have a situation where it works. Did I write that wrong? Oh yeah, 9.75. It's negative 9.75. Yeah, I just wrote that wrong in there. Yeah, you're right. That should be negative 9.75. Yeah, good. Okay, here we go. Should have come up with 25 nickels, 14 dimes, and 39 quarters.
No, look at. Because all I had to do was yeah. No, are you, bro?
And remember, we talked about the other day too, like if the decimals become too taxing for you, multiply everybody by 100. Just do both sides of the equation, then you can work with whole numbers. Or integers, I guess I should say. I hear that every year. I know. A lot of writing. It's tedious. It's tedious. Yeah. Yeah, right? Think about how long it takes me to grade those. It's a lot. Oh, gosh. Challenging. Okay.
What?